exactly what's going on.
Quite incredible. Look at the color in them. Just think they look like part of the sea, but they're green like the sea, and purple. It's so nice to hold them in my hands. The first time I've seen these. I've never seen them before. We're going to repeat the process of how they did it 3,000–4,000 years ago, but not only that, but in this very same place where this was done, at Tel Dor.
Here we have the trunculus. Inside you have like the kind of worm, the snail inside the shell. Right about here, on the back of the worm, there's what they call the hypobranchial gland.
Right.
That's where the dye is stored, and that's what we're going to get to. So we're going to try to break that open now.
Now you break it right at that point.
Right at that point. And here you can see, there it is. You see that? This whole yellowish gland. That's what we need. That's where the dye is stored.
Okay. Just that yellowish gland there.
That's it. Yeah. So
Okay.
we'll take this off.
Okay.
Now inside the gland, there's this kind of a clear liquid, which when exposed to air and the enzymes that are also in the gland, will change the clear precursors of the dye into the dye itself, and you'll see this getting reddish, purplish blue in a few seconds.
Does it need the sunlight too?
Well, some of the literature says it does, some of it says it doesn't. So I don't know the answer to that question. Here, we'll just do it again.
That's all. That's the whole gland. That little thing. Not the yellow part, but just that little thing up
We'll do it
top.
again. Here, we'll just do another one.
Okay.
Can you see?
Yeah. Oh,
There you
that's
see the
beautiful.
gland.
Now I see very clearly the gland.
You see that? This whole area here.
Well, I might as well try to cut it out. Why not?
There you go.
Just this gland over
That whole
here.
thing.
Just the little dark part.
Right, exactly right. That whole thing.
No?
Now you
That's
got
some
it.
of the yellow
That's
part.
good.
Yeah.
You just put it right down.
Now I need to get it on my finger. Nothing's gonna happen.
No, just your fingers will turn blue.
Finger will turn blue? There it is. That's the gland.
Right.
That part.
Now you can already see,
Yeah,
in a
this
few
one's
seconds, this is already turning.
You can't eat this?
People all along the Mediterranean eat them, and we've asked that they give the remainders of these snails to the poor people in Jerez to eat. Also, I've just read recently that derivatives of these chemicals are used in leukemia research.
All the remains at the archaeological sites, and in the seashells as well, show us a purple color, the argaman, known in chemical terms as dibromo-indigo. But what of the Tekhelet, the blue color mentioned in our sources? Our journey takes us to the chemistry lab, where we will learn for ourselves what the ancient dyers knew long before us.
Any time they've ever found any sort of archaeological dye, the archaeological sites, the pots that they found there, and we've done analysis on this stuff, it's always been only dibromo indigo. This was the big problem everyone felt, all the scientists, the historians felt that this snail was it. But what? But it's purple, it's not blue. Till about 20 years ago. 20 years ago, somebody was doing this in a lab in Tel Aviv, and he put the chemicals in, and he put the dye in, and he needed a coffee. So before he put the wool in, he took this pot and he put it on the windowsill. And it sat on the windowsill for 10 or 15 minutes, and the sun hit it. And he didn't realize it, but what happened? The sun broke the bonds of the bromine atoms. Once the bromine atoms disappear, what are we left with? Not dibromo indigo, indigo. Indigo is a blue color. Indigo is the color of blue jeans. Levi's blue jeans were traditionally made with indigo. So now what happens is, you put your chemicals and dye in. You let the sun hit it for a few minutes. You then put your wool in. You're not putting your wool into a solution of purple dibromo indigo. You're putting your wool into a solution of blue indigo. You cook it, and when it comes out, you have this beautiful blue.
To see the Tekhelet chemistry is something entirely new. The actual chemistry is something we only learned this century. It's good to see that knowledge rediscovered. It's a chemistry that came from people and should be returned to the people.
There are three clues which will help us identify the true Tekhelet. The first is that it has to come from a sea creature. As the Tosefta says, Tekhelet min achilazon kasher. It has to come from a snail, from a conch, from a chilazon. And that we've already seen. The second criterion is that Tekhelet has to be a steadfast dye. It has to be fast within the wool and not fade. She'omedet b'yofyo, says the Rambam.
According to Jewish tradition and Jewish law, the dyeing of wool as Tekhelet has to be a permanent dye which does not fade. It does not fade when it's laundered again and again. It does not fade when it hangs in the sun, exposed to the sun, and it doesn't fade due to rubbing and in its use as a textile. We have found that the dye stuff, which is based on a ring system of the indigo, this is the chemical basis of the Tekhelet dye produced by the trunculus shellfish. And we can certainly say that regarding the ancient world, it was the most permanent and stable dye stuff that they could ever find.
There are lots of things which stain something colored. I mean, even if we eat some berry or something. But the trick in making a good dye is it has to be fast. It has to. No one's going to buy a shirt that's going to wash out the dye in one day, in one wash. So this is now fixed into the fabric of the wool.
Third criterion, which we know from the Gemara, is that it has to be identical to a counterfeit Tekhelet, a counterfeit dye, which was rampant in the times of the Gemara, and that was called kala ilan, or indigo. It came from a plant source, from the woad plant or the istis source.
This plant, which can produce the indigo dye, another plant known as the indigofera species from India was most probably the kala ilan or kela ilan of the Talmud. The plant and the dye that the Talmud warned against using because it was very difficult to distinguish between kala ilan and real Tekhelet. However, in today's world, with a liquid chromatograph that we have seen earlier, one can definitely distinguish between an indigo that is plant-derived from indigo that is animal-derived, because in the animal-derived indigo, that is the snail-produced indigo, one can also see dibromo indigo, which can only come from a snail and not from a plant.
Now we know that Medrash in Baba Metzia that says only God can distinguish between them. Why? Because they're absolutely identical. So of course you can't distinguish between them.
The search for Tekhelet for Tzitzit brings together two ancient crafts and industries. We have already seen the dyeing process reenacted. Let's look at the ancient textile industry, the spinning of wool into thread to be woven into fabric for clothing and other uses. Tzitziot are made of wool. The process of making them reminds us of the process used in the desert by our ancestors in building the Mishkan. The rabbis of the Mishnah organized the concept of work that one rests from on Shabbat into 39 major categories called the 39 Avot Melacha. These categories were used in the building of the Mishkan. The loom is used for weaving the thread into fabric, but for tzitzit, the spinning wheel is where it all happens.